the splitting of glucose into two molecules of pyruvate. And we have ATP, which comes along acting as the activation energy to split glucose in half. And then NAD is reduced to NADH. We have two molecules of that. And then so ADP gets phosphates and becomes ATP. So then we have two net total of ATP. And we have two molecules of NADH. Next we have the link reaction, which is when pyruvate goes into the mitochondria's matrix and hits coenzyme A. It's oxidized and creates CO2 and acetyl CoA, and then also NAD is reduced to NADH. So we have a molecule of NADH. Krebs cycle, acetyl CoA will join with oxaloacetate to make citric acid, followed by a series of reactions which will make 2 net ATP, 6 NADH, and 2 FADH2, and release 6 CO2. This makes citric acid back into the oxaloacetate, releasing energy with every cycle. The electron transport chain begins with NADH being oxidized and the hydrogen going up through the protein channel and creating a concentration gradient. The electron will then bounce along the protein channel, and then sequentially, the same thing will happen to FADH2. The hydrogen will go up through the protein channel, it will become oxidized, and then the electron will be passed along the protein channel. And then we've created that high concentration gradient, and that hydrogen will come back down through the ATP synthase, and those electrons will help it bond to make water, or H2O. And phosphates will be binded to ADP to create ATP, and we create 32 to 34 net ATP, 6 NAD+, 2 FAD, and 6 H2O.